In this video, we're going to learn what a geometric sequence is using explicit and recursive formulas. Here's a definition of a geometric sequence. A sequence in which it has a common ratio from one term to the next. We call that common ratio R in the formula. Here's the explicit formula for a geometric sequence. I would write down this formula and what the pieces are. If you need more time, go ahead and pause. T sub 1 represents the first term in the geometric sequence. T sub n represents any other term. Usually we represent it as the last term in the sequence, but it doesn't have to be. And then n represents the number of terms in the sequence. To find the common ratio, the R, you pick any term in the sequence and divide by the previous term. And I would do this twice to make sure you have a common ratio. So that's your R. All right, here's our example. Write an explicit formula for the nth term of this geometric sequence. So we give you term 1 to be 250, term 2 to be 100, term 3 to be 40, term 4 to be 16. And we want to find out what is the common ratio and to see, do we have a common ratio? So to find the common ratio, you just start at any random term. So I'm just going to start with term 3. And I'm going to divide it by its previous term, which would be term 2. Not substitute those numbers in. Term 3 is 40. Term 2 is 100. And now we're just going to go ahead and reduce that fraction down. So 40 divided by 100 can be written as a fraction or as a decimal. Either way, it doesn't matter. So if you wanted it as a fraction, then it would be 2/5. As a decimal, it would be 0.4. The other thing we need to know in the explicit formula is what is term 1, which is 250. Now we're set to do the explicit formula. So the explicit formula is back on this slide, right here. T sub n equals T sub 1 times R raised to the n minus 1. So T sub n is T sub 1, R raised to the n minus 1. And now we're going to go ahead and substitute in the term 1, which is 250. The common ratio, either you can leave it as a fraction or leave it as a decimal. It doesn't matter. I'm just going to put it as a decimal. And then n minus 1. So there's your explicit formula. Now what we can do is, with that explicit formula is go out and find other terms in the sequence. So here's an example. If I asked you for the 5th term in the sequence, we would use this explicit formula. T sub n, 250, 0.4, raised to the n minus 1. And what our n would be 5. So we say 250, 0.4 raised to the 5 minus 1. Now we're going to go ahead and reduce the exponent first. Remember our orders of operation. So 5 minus 1 is 4. Then we do our exponent. So we're going to say 0.4 raised to the 4th power, which is 0.0256, and then multiply it by 250. And our next term in the sequence is 6.4. There's term 5.